So, hello friends. Today we discuss testing the significance difference in the single sample mean when sigma is unknown. Already this procedure is discussed in the previous class. So, this is the procedure. Already we know. Let x1, x2, xn are random samples drawn from normal population with mean is mu, population mean, and varying sigma square. So under this assumption, the test statistics T is given by x bar minus mu by s by root n. It follows Tn minus 1 degrees of freedom, where we know x bar value sigma x by n, but s value we know other s square value under root 1 by under root of sigma x minus x whole square by n minus 1 s value. So we know conclusion according to our calculated T value is less than our table value, accept, otherwise reject the null hypothesis. So for example 1, a company claims that the average life of computer is 3000 hours. A random sample 5 computers were tested whose averages are given. So 3000, 110, 2995, 3006, 3000, 3010. Test whether a company claim can be accept or not. Test at 5% level of significance. So this is the table value already given. Otherwise can available in T table values. Okay. So first of all, the solution nothing but define first null hypothesis, then alternate hypothesis. What is level of significance? Then test statistics, then conclusion. So this is the procedure already we know. So now define null hypothesis nothing but mu equal to given the average life of computer is given mu equal to 3000, and define now alternate hypothesis. Alternate hypothesis nothing but see here mu is not equal to 3000. Here there is in this problem there is not given either less than or more than hours of average of this 3000 hours. So that is why we take that here two-tailed test nothing but mu is not equal to 3000 here. So now here what is our observations given? N value is nothing but 1 2 3 4 5. So n equal to 5, and so here x bar we have to find out, and mu is nothing but this is 3000. So we know level given, and also given level of significance is 5%. Okay, 0.05. The test statistics formula we know x bar T equal to x bar minus mu by s by root n. It follows Tn minus 1 degrees of freedom. So this our LHS value we want to calculate. For this we required one table, nothing but given one column is xi values, given observations, and also xi minus x bar whole square. Okay, the second column required because we require s square value. Okay, so xi values, so x1, x2, x3, x4, x5. Then what is x bar? Nothing but we know x bar equal to sigma xi by n. We get average value. So now from subtract from each observation, then square on, we get this is the value. So this is value is nothing but here xi sigma xi minus x bar whole square value. So now calculate s square value sigma xi minus x bar whole square by n minus 1. So this numerator is nothing but this 172.8, n minus 1 nothing but 5 minus 1 4. This is called 43.2. Then find s value 6.57. Now calculate T value is x bar minus mu by s by root n. X bar value, then mu value, here s value by root n. We get this our calculated T value. Now comparing with table value. The table value is given at 5% level of significance with n degrees of freedom, nothing but 4 degrees of freedom, 2.776. Comparing this to here the table value is I. Comparing this our calculated value. Hence the conclusion nothing but here our calculated T value is less than our table value at 5% level of significance with 4 degrees of freedom. Hence our null hypothesis is accepted. Therefore the average life of computers are 300 hours. So this is the conclusion. Okay. Similarly go for example 2. Okay. So same given the average marks of student in a classroom is 39.5, and The standard deviation is given 5.6. A random sample of 20 students average marks is 42. Test whether all the students are drawn from the same population or not. Okay, so here also, so you're comparing here, the sample size is less than 30, we can apply the t-test, and also given the samples are given and population mean is given, according to define our null hypothesis mu equal to 39.5, alternate hypothesis mu not equal to 39.5. so this is called average of the class marks of 39.5. okay, the level of significance is given. If not given, we take 5%, no problem. Okay, there is a given level of significance 5%. The test starts in formula, we know t equal x bar minus mu by s by root n. Here we can apply the here, so s is nothing but is small s by root n, comparing. So then t n minus 1 degree. So see here, n value is, sample is given, size is given, n equal to 20. So average of this, nothing but sample average is given, x bar is given 42 directly, mu also there. A sample standard deviation is given 5.6. Comparing the previous problem, this in previous problem is not given x bar, you are given directly, and also not given s, you are given directly sample variance. So substitute x bar value, mu value, s value, n value, we get 1.996. This is our calculated t value, comparing with table value. So observing here also, the table value is very high. Here the calculated t value less than the table value, and accept our null hypothesis. So this is for example 2. Next, so the next one is the second case example. The testing the significance difference between two sample means. Here sigma is unknown. So different according to procedure, we know under null hypothesis mu1 equal to mu2 or sigma 1 square equal to sigma 1. So there is no difference between the population means. Under h1 mu1 is not equal to mu2. Okay, so according to level of significance here, degrees of freedom. This is a formula we know, the procedure already discussed. Once again see the t formula, x bar minus e of x bar by standard over x bar. So comparing, so after simplify the procedure, so this get the formula here, t equal to x1 bar minus x2 bar by under root of s square into 1 by n1 plus 1 by n2 follows t n1 plus n2 minus 2 degrees of freedom. x1 formula, this is average of sample 1, average of sample 2 is x2 bar. S square formula, this is 1 by n1 plus n2 minus 2. This is sigma x7 is equal to whole square, where I equal to 1 to n1, j equal to 1 to n2, x2j minus x2 bar whole square. This is called a pooled sample variance. Okay, so our same conclusion already discussed. Our calculated value is less than table value, accept the null hypothesis, otherwise reject the null hypothesis. See that one example. Similarly, okay, before that example, better, and also what is the F test? The F test nothing but test the equality of variances. Here under defined null hypothesis here, sigma 1 square equals sigma 2 square. Null hypothesis nothing but after that h1 not equal to sigma 1 square not equal to sigma 2 square. Here test of equality of variances. Okay, the t test is formula nothing but the ratios of s1 square by s2 square. It follows f the degrees of freedom corresponding. So v1 comma v2 nothing but n v1 nothing but n minus 1 comma n2 minus 1 degrees of freedom, or s2 square by s1 square, because in this case otherwise this better is always understood here, greater variance by smaller variance. This nothing but called a F test. Same as is the inference nothing but conclusion same. F calculated value less than the table value at degrees of freedom, level of with corresponding level of significance, we accept the our null hypothesis, otherwise reject the null hypothesis. Where what is s1 square formula, this one s2 square formula. Okay, so just calculate s1 s2, substitute here, we get f value. Now according to our conclusion. Okay, see that one example. See here, test the equality of means and variance at 5% level of significance. So given, so data 1, data 2, so given samples here x1, x2 nothing but, okay, either xi, yj or x1, x2. So x1 observation given, x2 observation given, just find out, take the average values, this x1 bar, x2 bar, So now subtract, and x1 minus x1 per whole square, x2 minus x2 per whole square, we get this value. Okay, so now this is, we can find out this s square formula, simplify, we get s2 square s value. So after s value, okay, you can substitute in t formula. So what is the t formula? We know all the calculate t value. So this is the t formula. Nothing but is x1 bar and x2 bar under root of this value. Okay, here. Okay, so t value, comparing this with corresponding value, we get t calculated value, comparing the table value. Here also the table value is high compared to calculated value, hence we accept our null hypothesis. Similarly, same problem, we can use those equal variances, nothing but f test. F test is nothing but the same, s1 square by s2 square, or s2 square by s2 square. So greater variance by smaller variance. So that is why you can apply the formula. F calculated value here 2.9, but f table value, okay, table value comparing f table available already, but already given the comparing the table value at degrees of freedom 5,4 at 5% level of significance is given 6.26. Comparing here also, that is accept our null hypothesis. So this is the conclusion of problem. Okay, so these are simple examples, you can understand one by one. Okay, so see that already given some examples, so please try it. Okay, thank you friends, thank you.